would be interesting to discuss, what's the meaning of this neuronal activity that goes in the opposite during this perceptual suppression. Come up with some kind of model to explain why this kind of thing happens in the student discussion. I don't know if everybody got this, meaning of this weirdness of this finding.
Yeah, so intuitively, right? You would expect, okay, you show something and you take it physically away, and then so you have a cell which responds to the stimulus. So, and clearly that's the case, right? They are by definition sorted that way. I took only cells that were responding to this red target stimulus, and yeah, and then you remove the target physically. And the cell would increase the firing and so the perception. I guess in the webinar we may get back to that question. And maybe should we just decide later whether we want to discuss it or not? Because I think there are two things. One, that also the sensory processing can go the opposite way, and then the perceptual processing can also go the opposite way, right? So yeah, and you also have inhibitory cells, and I think that we can try. So if you're interested in it, we can discuss it. But
can I ask you a question? So in this case, how are we sure we are looking at the response to target rather than to the suppressing motion stimuli? Is a way to dissociate the response to target from?
Yeah, because here there's only a target shown, and so yeah, so you get. So you mean here? It's always an interaction. It's always an interaction between having the target and the surround. And how I know that, because I also run controls where I was just showing the target or the surround.
Yeah, so that in that sense, larger response for the invisible condition might be the larger response to suppressive motion.
Yes, it could be. Only that in this case, the physical stimulus is always the same, right? It's just the perception that changes. But yes, it actually, to me, I would think it's always an interaction between the surround and the target. And I would even maintain by now that we sort of have to look at what the surrounding pattern is actually doing and how they interact much more than we used to do it. I was sort of thinking always just about the target somehow.
That explanation, I think, doesn't make sense. So that function for the physical removal, that means that you don't show the red dot, but you show only the surround at that period of period after the initial dot presentation, right?
Well, if you do remove the target physically, then yes.
Purple lines. Initially you show red dot only, and then at the offset you remove the red dot and present only the surround. That's the
yes. But the thing is, it will be still. I mean, you get really a complexity of responses that sort of it does not. Yeah. So usually,
what I
like
wanted to say was, Amano-san's suggestion that it is just looking at the response to the surround can be excluded by the fact that only to the surround response is much lower in that case.
But if we assume indirect compressing.
Yeah. Then yeah.
Yeah. And yeah.
So it's just very. Maybe I was distracted, but how do you know where the gaze is?
Oh, the monkey is always fixating in a super small window.
How?
So in earlier days, the monkey had an eye coil implanted. So so this is how you would also do human experiments. You calibrate the space. You let them look at the different places. And then you say, okay, such big eye movement corresponds to how many visual degree. And in those experiments, I still had used like 0.5 visual degree angle. So it's really, really small. Like with a human eye tracker, we use like 1 or 2 degrees or something like that. And then the way I had programmed the task is so the computer was continuously checking whether the eye was still in the window, And when it was not, then the trial would be automatically aborted. Yeah, that's actually really important, especially if you're in early visual cortex or in the LGN. Yeah. I can't actually, I have to move on. So, and then this we haven't done with this perceptual suppression paradigm, but it has been done in binocular rivalry. As you go then more even higher in the visual hierarchy, so there basically the cells completely correspond to what the percept would be. So this is the general principle, which is really a conclusion from many studies that also have been done with the structure for motion stimulus, for example, you have just seen. This is the, so this is the principle that sort of got crystallized out based on the single cell responses. If you look at the first order of visual processing, the LGN, there's really no cell that corresponds to the perceptual state. They just go with straight what the physical stimulus would be. In area V1 and V2, there are a couple of cells, but perceptual modulation is sort of small. And then as you move higher, or even towards the parietal lobe, you get more and more cells which are corresponding to the perceptual state. Also in the higher order visual thalamus, pulvinar, I will get later to the structure because it's a really interesting one. And yeah, so from a monkey electrophysiologist single cell perspective, the pattern looks like this. It really looks like a hierarchical system, sort of. So now a question arises, is this actually the point once the processing has reached the temporal lobe state, is that the moment where your phase perception, for example, pops out? So this is still the classical grandmother's hair problem. However, there are some more conceptual troubles with this hierarchical model, because first of all, the actual number of possible percepts surmounts the number of neurons. So that's just a theoretical problem. I didn't model it myself. Yeah, I have to believe that.
What determines the distribution of possible percepts?
I guess if you I always imagine it as like the number in the alphabet. You just have 28 or so German letters, but you can do a sort of infinite combinations. And so you have different colors, you have different combinations, you have so many. I cannot put a number.
But I don't know if I've had 10 to the 11 different experiences in my life that I could actually distinguish. 10 to the 11 is a big number. Right,
It's pretty big.
So.
10 to 8, I cannot calculate that.
I'm just curious where the...
Yeah, I took it from modeling papers, and as I said, like I have to trust this number. I always found it very intuitive, because even with the small, you have so many different colors and orientations, and so it was very intuitive to me that the combination would be a sort of infinite.
It would be actually interesting, even project or proposal, final proposal, or the discussion today. How can we actually estimate actual number of possible percepts, even if you limit it in the visual domain? Well, what's the method to estimate it? And I actually don't know, and I'm always curious about how many possible percepts we can actually have.
Like in a lifetime?
In a lifetime, or at a given moment right now, there is a multiple ways to define this thing. Probably, I can think of something, but maybe you have different kinds of definition or methods to estimate that number.
Okay, this is the model. Why we have modelers here? So that's the modeler's job. So let's add that to the study questions.
So the actual number of possible percepts.
How would you estimate them? Yeah.
What is a percept? Is that momentary?
Yeah, I had this question too now. You meant like through lifetime?
That should be also included in that discussion. Or
But yeah, I mean, on the empirical level, the problem, I mean, to me, that is sort of the most convincing counter evidence that the system works that way, because if you do have a lesion in the temporal lobe where the cells are all showing strong perceptual modulation, you don't get problems with your qualia. You still would perceive, for example, a face, like in terms of you see something with features. The problem is you would patients with temporal lobe lesions, they have something that's called visual agnosia. So they may actually confuse like where the face is, or they may not be able to draw like a full object, but they make that possibly line by line. But they would still have a visual experience. So it's almost more complex object recognition problem, but it's not a qualia problem those patients have. Mm-hmm.
Are the qualia different in both cases, or would you say, well, the qualia are the same, just the interpretation given to them are?
I actually.
Yeah.
There are also different types of agnosia. There's one type where the patients would really draw line by line and not the full object. So, yeah.
At least your gestalt is different, right? Maybe that's a more.
Yeah, exactly. That would be the gestalt perception. And then there is a different type of agnosia that also comes with temporal lobe lesions that is more conceptual, that the patient really cannot tell whether, so they don't have a language problem. So they would say, okay, this is now a toothbrush instead of whatever, a wish mop or something. So yeah, there is more lower order, but the ones who are also drawing interrupted like this, maybe they perceive it that way. It's really difficult to tell, right? Yeah. Good question.
That's also an excellent question, actually.
Yeah.
We possibly discuss, would it be actually possible to experience something like that within us? And how would it feel if you don't have that kind of concept? Does it actually look different, appearance-wise? Or appearance continues to be the same, but, we just, attach the meaning. Does the quality actually change or not, right? Yeah, basically.
That's also the question, like, can you disentangle appearances from the meaning, right? I mean, probably that's the old question, but I would think no, but perhaps.
I'm actually curious how phenomenologists, people think about this kind of question, whether appearance-wise, phenomenology-wise, with or without meaning, the same thing actually looks same or different.
I mean, I know.
Dog kind of stuff, possibly.
I know one study. I have forgotten the author. Unfortunately, it was a PNAS paper, just maybe 2 years ago or so. They looked at the influence of language on perception. I mean, this is sort of the most extreme concept you can have, right? It was the Russian speakers versus the non-Russian speakers, and the Russian speakers, they had like different names for, I think, the blue, and then they did a psychophysical experiment to show that they really could discriminate better between the different colors. So it was like a really hardcore visual psychophysics experiment. So I need to look up the author, but I sort of see.
So there is indeed like in linguistic relativity hypothesis, there's lots of these kind of experiments of how your language or your conceptual scheme can influence the way you perceive the world. So this would be more like a top-down, conceptual-driven view of perception, where some bare sense or some bare awareness doesn't play a big role. And these things are actually like the bare sense, the bare awareness is not perceptible in that sense. It's always kind of top-down, laden with meaning. But I think it will be an interesting question to see how also like related to neuroscience, like how can you disentangle these things, or can you dissociate between pure awareness and
the concept.
Another question.
It's good, yeah, it's good study, yeah. I obviously I don't know, but
every perception of every moment is so rich in context. I mean, additional example, if you for a moment show that somebody's putting a knife into somebody else, it could be a murder mystery, it could be an accomplished surgeon. I mean, you just don't know unless you know more about the background. So the number of counts of momentary phenomena you can be aware of, that can be defined, but that is like syntax versus semantics, but the surrounding can be very round. I guess one way of counting the number of percepts in a lifetime, you can say this is the largest possible size of a diary.
Do you think that makes it better?
Like you spend every moment recording what you see.
Oh.
A diary can never be larger than the number of percepts you have in a lifetime. Of course, you can reflect on it. That is again from syntax to semantics. If you reflect on what happens, it can go on forever. I mean, we know people who write emails and it go on forever.
But without repetition.
Yeah.
Without repetition. If you repeat yourself.
You're thinking about Go.
Yeah.
Okay.
Anyway, yeah. But if you want to make that a question, do you want to formulate
Yeah.
it? Can you say again now how you want to formulate the question, or Melanie?
Like, maybe you can formulate that.
You did already formulate it. Does awareness, is there awareness without concept?
Right, yeah. Does it make sense to think about pure awareness without conceptual top-down modulation, something like that?
Yeah, but
Yeah.
pick one. Can you say it slowly enough that
Yes.
it can make it down?
Oh, I forgot what it said.
We're still writing.
No, if you can say one sentence, you say this or that, I cannot type quick enough.
Does it make sense to talk about awareness without, let's say, top-down modulation? Is that a way of framing it?
Well, maybe
Top
another
down.
way of saying it's like, can meaning change the appearance?
I think the answer is yes.
It's just, I mean, there's a huge debate in philosophy of perception, whether perception is conceptual or not, where you can have non-conceptual perception. And it's not obvious that you can solve the question empirically, because it depends on what you mean by concept, what you mean by meaning, what you mean by... So, yeah, I suppose that would have to be integrated with all looking at that literature as well. And,
Yeah, so we need philosophers' help for this. So we should do the discussion groups like in this way. We need one modeler, one philosopher, and possibly one. Yeah.
So let me do it in two ways. Does it make sense to talk about awareness without?
Mathematician we need.
Without what?
Top-down modulation.
Without top-down modulation, whatever that may mean. So if we define everything, it gets too long. So modulation, we can talk about that too. Or can meaning change appearance? Okay, good enough. Thank you.
Can I just make one clarification question? Can you go back to the previous slide? And I wasn't sure about what these arguments, the view these arguments are against. So the hierarchical model of conscious perception. Can you explain what this
Hierarchical
model was
just
again?
sort of the feed-forward thinking that at the end you have like one neuron which integrates, which basically represents one percept, like one face, for example, for you in your.
So is that
awareness.
a view about the neural correlate of consciousness?
Yes.
Okay, so
So yeah.
And then I'm not sure how this second objection works,
because the same neurons, if you say the temporal lobe contains the neurons, and it looks like that if you just look straight at the neuronal modulation, then the question becomes, what happens when you lesion this area? But when you lesion the temporal lobe, you don't get problems with qualia or maybe some higher order thing, but the patients would still perceive.
But you said that the patient has a different conscious experience.
No, I didn't say that. They they may not be able to say what to do with an object, and they sometimes we really need to discuss it separately, I think, because we are going to get stuck. But when they draw, they would not draw it as a full, but they would still be able to copy. But they do it sort of line by line, but the lines are still there, so it's not that they lost their perception of the light.
Okay.
So
right,
I need to move on because the cool stuff is still coming. So, okay, now has talked about this yesterday. So this is your alternative model. I personally find very attractive. I'm not such a big fan of the frontoparietal notion, but it is, of course, reasonable to assume that in order to integrate the full information, the cells somehow need to communicate. And how would they do that? One very attractive framework is that they do that by oscillating in the same frequency and having communication channel open that belongs to a certain frequency. And that can be on with different frequencies. And in fact, right now, the notion in the field is not from the consciousness field, but attentional field, for example, that feedback connections, they would be more, for example, from the frontal cortex to the visual cortex would be more like beta frequency channel, and while the local or the feed-forward channel would be more the gamma range. But it's still questionable, but